Hi everyone, my name is Abel Gray Cantoma from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number or you can call me on any of these numbers, okay? Today I'm going to be talking about the base, which is the footing, okay? So we are actually going to be designing a particular footing today. And let's come back to our general arrangement in our AutoCAD. We actually selected a particular column that we did a design for, and whatever load that is coming on your foundation is coming from the load on the column, because the loads are distributed from the slab to the beam takes it to the column, and the column takes it to the foundation. Now, if that is correct, the axial load that we were able to get in this column design was 222.74 kilonewton. Now, if that is correct, all I need to do is to bring it back to my spreadsheet here, and then I will insert that information down below, which I'm going to be showing you. But firstly, very important, you need to type in the grade of your concrete, then you type in the grade of your steel, and then you need to put in your concrete cover, the density of your concrete, the soil bearing capacity. Very important. It varies based on region, it varies based on location. We have for most part of Lagos Island, they have a very poor soil, and then some part of all these riverine areas like the south, some part of them that are close to the rivers, their soil are a bit bad. So these are the average soil, the types of building. We have good soils, which is over 100 kilonewton per meter squared. The soil we said is good. The average soil is from 70 to 100. Poor soil is from 40 to 75. Bad soil is less than 40 kilonewton per meter square. But today we are actually going to be considering 150 kilonewton per meter square. I took this screenshot from an old video I did a long time ago, but that video is still very valid even till now. Like, the RCC spreadsheet is the RCC spreadsheet RCD 2000 are the closest to a manual design. So I will always encourage you as a beginner, if you are just a fresh graduate in civil engineering, or you are still in school and you want to actually get to understand design as a young engineer, I will always encourage you to start with the spreadsheets, or you can start with the RCD 2000. Okay, so let's jump right into it. Now, since we are assuming to use a 150 kilonewton per meter square, that means we are assuming the soil on that particular site is a good soil. So if that is correct, but this value is not just an assumed value. These values are gotten from a soil test. So a soil test has to be conducted on the site. They will pick the soil sample, take it to the lab, and run the tests. From there, you can be able to know the soil bearing capacity of that particular site. So if that is correct, right now on this video we are assuming that that test has been taken, and the soil report that was given to us is 150 kilonewton per meter square. Okay, so before you embark on any construction on any site, it is advisable you run a soil test. All right, so coming back here now, and based on my general arrangement, I am assuming to use a footing of 1200 by 1200 and the depth of 350. But you can see, based on the information that is here, this software is suggesting, it will always suggest it says it's suggesting a base size of 1310 square, or 12 by 1455, or 1405 by 1200. So it will always suggest for you. If you come down here, you can see it's telling us it has exceed permissible. So what that means, based on the informations that are here, it has already exceeded the permissible. Now we will have to correct all of that by putting in the right information and changing whether the cross section of the footing, which is the length by the breadth, or we increase the depth of the footing. That's basically all we need to do in order for us to have a good result. So we must make sure that we are not having this warning. Okay, so you can see red messages indicate entry error. This page for single columns only. Use next page for double columns. This is telling us where we have a combined base, you can design a combined base here, but this is actually for a single as a column. So for in this case now, all we need to do is to type in that axial load which we got from the column, which is 222.74. that is the value we actually got from there. And this imposed load is actually a value you will get, you can see, exceeds 1.2 permissible. So there is also another problem that has been added to this. So it will be advisable for us to increase the width of this particular footing. So I'm going to increase it to 13 by 1300. So let's see what we have. Okay, the other error has gone. So I'll try something else. Oh, I just hope the depth, I'm going to change this depth to 400. Let's see what we have. Increase depth. I'm sorry, 300. Okay. Increase this to 400. Okay, we are not there yet. It is suggesting I want it to be a square footing. Okay, for it to be square, we'll have to use 1440. So I can change it to 1450 by 1450, and let's see what we have. Good. Now you can see everything has actually passed. That error message has gone. So what is actually contributing to this is also this bearing capacity. For example, if I increase this bearing capacity to 200, you will discover that even when I drop, you can see by just increasing the bearing capacity, that means I am assuming that this soil is better than what the initial information I specified. So if it is 200, 200 is better than 150. So you can see it is assuming a 1450 by 1090. So what that means is that even if I try to use a 1200 size of footing for this, is going to actually work. Let's see. Okay, it has exceeded a bit. Even this depth of footing is too much. So we can as well increase the depth, but if feeling like the depth of 400 is already even high enough. But okay, what I will do is leave it at this, and then I will change this to 13 by 13. But mind you, this is actually the most critical column of them all. So if whatever information or whatever I'm getting from this design can cater for every other footing in the building, okay. So but you can probably test or do all the parts individually to know if the other ones can go a bit lesser, which I am sure you can have a lesser value when it comes to the cross section of the other ones. The other footings could probably be less than 1300 by 1300. 1200 will most likely work for them. So the other footings like this ones, and the other ones could 12 by 12 will most likely work for them. So this is basically how to come about your footing design using your spreadsheet. It's very simple when it comes to the footing, because the major work has already been done in terms of knowing the load from the column. All you need to do is just to pick that load and you impute your values, and it will design it for you automatically. It will go as far as giving you the reinforcement and the spacing of the reinforcement that you should use. So you can see along the X direction and also along the Y direction is asking us to use Y12 at 150 spacing. Okay, so if that is correct, and if you love what you're seeing, make sure you like this video and give it a thumbs up. Subscribe to this channel. It's actually 100% free. Click on the bell icon so as for you to get a notification whenever I post videos like this on a weekly, sometimes on a daily, just for us, in order for me to encourage as many that actually want to have a deeper insight of design. Okay, please, I will encourage you, if you are not an engineer, please be one. Structural design is very sensitive. It deals with a lot of safety. So by the time you do your design wrongly, that means you are about to actually bury some people alive. So let's be very careful, because structural design is very sensitive, deals with safety. It deals with safety. So you must make sure you have a background in civil engineering for you to embark on structural design.